Hello everyone, I am Hamza Ashraf with my groupmate Raja Atif Rashid. Today we are here to present our final year project that is AI based tracing of game addicts and non-addicts using EEG data. This project is supervised by Dr. Ahmad Ali Shah, and we are here to present this project and doing this using the artificial intelligence. Now coming toward the content of this project. First of all, we will do the introduction, then we will go to motivation, then pros and cons of video game, then the problem statement, then literature review part, then aim and objectives, then the methodology working, then the result and discussions, then the conclusion, future recommendation at the end, the references of all the data we obtained. Now, coming toward first part, that is the introduction, the game addiction. Actually, we got the idea of game addiction from many papers, like they are representing the addiction of internet and many other things. We get the idea that there are many things that is happening in the game addiction. Many people died because of game addiction. In this project, we are using the EEG data from that we get from our brain using the headset that we use the OpenBCI headset. We get the data from the brain using the EEG signals. Thus, device that we are using, that is OpenBCI, because that is cheap. Then we will apply different algorithms of artificial intelligence to get the maximum accuracy. Now, coming toward the chapter number two, that is motivation. In the chapter two, we get the experimental and psychological research. We do the online gaming disorders, health and education. Like in the motivation, as I already mentioned below, that before starting this FYP, we get many news like people died because of the PUBG. Here are some news. You can see the boy died of stroke while playing the PUBG mobile. In this project, we use only one subject, that is PUBG, and we use different characters, like we are using 23 characters to get the data in order to get the maximum accuracy.
And now coming toward the pros and cons of video games, that in today's world, video games are the most popular sort of the game that youngster plays. And here are the pros and cons of the video game. First of all, we come to the advantages of the video game. The number one and the first advantage of the video game that it improves the vision. The second one, it is used as a brain booster, and third, it is used as an improved life skill, and it may ease anxiety and depression. And the last disadvantage that it is used as a painkiller. Now come toward the disadvantages of video game. The first and the most disadvantage of online gaming is addiction, that while we continuously play a game at the same time we got addicted, and it affect our mental health and social. It also used as social replacement. And the third disadvantage is obesity. The fourth disadvantage of video game is stress, and the fifth one is it could limit academic process. And the last disadvantage of video game is violence. And now coming toward the problem statement of video games. Game addiction is an emerging dispute these days which roots many problems. And here are the some problems that we highlighted in our FIP. The first and the most problem statement is the social skill get poor. The second one is the academic achievements are highly affected. The third one is aggressiveness in behavior. The fourth is decreased creativity. The fifth problem is that low verbal memory performance, and the last one is negative impact on health due to stress while playing game. Now coming toward the literature review. In this section, we have analyzed some of the existing internet video game addiction to identify the limitation of such techniques. And here are the some research paper that we studied and we got idea to do this project. The first and the most research paper is the impact of video game addiction on student performance during COVID-19 pandemic. This paper is published in 2020 in IEEE journal. The study that has been done in this paper is the first one is demographic factor of video game, that how video game affect our personality, our academic performance and social activities. The third point is impact of video game addiction. Now, the second research paper that we study is that emotion recognition from EEG signal focusing on deep learning and shallow learning technique. This paper is also published in 2020, and the study that is done in this, the first one is emotion recognition from EEG signal. that how we detect and recognize the emotion using EEG signal that we got from the brain, that is the electrical activity in the brain. And the second study that is done in this paper is EEG data set management, that how to manage the data set and how to apply different algorithms to sort out the different techniques. The third research paper is the impact of online gaming addiction on adolescent mental health. This paper is published in 2021, and the study that is done in this paper, the first point is adolescent, that how a player from child to adult plays a game and become addicted, and it affects their health and well-being. And the third point is mental health. The fourth one is online game addiction. Now, coming toward the last research paper, that is video game addiction and emotional state, possible confusion between player and happiness. This paper is published in 2020, and the study that is done in this paper is first one, the emotional state, that they describe the emotional state of a player, that how it affect their activities and their emotion. The third one, the second point is video game. The third point is player and happiness, and the last one is addiction and confusion. And now coming to our the aims and objective of this project. This project is designed to sort out the addicts and non-addicts of the video game through EEG signal and AI. And here are the aims and objectives that we achieve. The first and the most the first and most important objective is to design a model that support addicted patient by processing EEG data using artificial intelligence. The second objective is time domain and frequency. In this objective, we apply the time domain and frequency analysis on EEG data to extract different bands like alpha, beta, theta, gamma, delta, different bands of EEG. The third objective is analyzing the EEG data. In this objective, we have analyzed the addiction from real-time data using artificial intelligence. And the last objective is to detect that analysis that we achieve. The last objective is to detect any distinction between addict and non-addicted game players.
Coming toward the chapter 7 methodology working. In this chapter, I will describe how we do this FYP project. Like first we do the scale based technique. We get a survey of different people that they are addicts or not addicts on the basis of their own surveys. Like we include different questions from 1 to 10, we scaling from 0 to 5, and then we obtain the data like how they are doing in the scale based technique. Then we record and analyze the EEG data using the headset. We use the OpenBC headset that I already described below. Then we applied the different AI algorithms, including the CNN, ANN, KNE, ResNeighbors, and the others, that including the decision tree and different classifiers. Coming toward the methodology working continue here, you can see there are different lobes of our brain, including the control scala, the frontal lobe, the temporal lobe, partial lobe, and the occipital lobe. Here you can see in the occipital lobe, we have the visual related task, like we are doing the project on the visual related task. We are working on the game addiction. Here the people need the mobile phones or the visual effects to get the data of occipital lobe. Like if a player plays a game, so he needs to detect the visual effect. He need to make the proper statements regarding the occipital lobe. Here are some working this research is done in our lab. Like here you can see there are different lobes of our brain, including the occipital, frontal, and the others. We use the occipital lobe because it includes the visual related tasks. Here you can see the O1 and O2 are two different channels that use the visual processing task. Now here comes the experimental setup workflow, how we did our project. First, we get the data of EEG using the OpenBCA headset. Then we pre-process the data using DWT formula and the MATLAB. Then extract the features of different bands, alpha, beta, gamma, and delta. In pre-processing, we apply different filter to completely exclude the noisy signals of eye blinking and others. Then we extract the picture using DWT in alpha, beta, gamma using DWT formula. Then we classified into addiction and non-addiction. Now coming toward the methodology working part, how we did our project. Like first we do the scale based technique, then we experimental design, then we get the signal and then process the signal, Then region rectification analysis including the time series and frequency domain. In the time series, we get the cross correlation like the person is addicted or not addicted using the scale based technique. Then in the frequency domain, we extract the features using DWT in the alpha, beta, gamma band. Then we filter the data like if we don't want the noisy signal, what we have to do? We will apply different we will apply different filters including the Asgole filters. Then we apply different AI algorithms and then train on different algorithms including CNN and ANN, the artificial neural network. This is a part of data acquisition, like we get the data of EEG using the OpenBCI headset. There you can see here the electrode cap that we use to get the data. Here you can see, and then the Cyton board, and then the programmable dongle that we connect with our PC. Now coming toward the first part, we use the OpenBCI headset that contains two sensors, like we use the O1 and O2 occipital lobe. We include 23 participants and we get the data of that for 25 seconds while playing games. As we have used only the PUBG game, so we have only one subject related to the game. So 23 participants get the data. The feedback responses of addiction, non-addiction is collected from the subject for each gameplay. Like we give a person 25 seconds to play a game and then we record the data. Now coming toward the second part, that is data acquisition. Here you can see there are the raw signals from channel O1 and O2 of subject 1. Like subject 1 including there are 23 subjects we have using the PUBG mobile game only. So here is the raw signals of occipital 1 channel and occipital 2. Then we go to pre-processing. In pre-processing, we use the S-Gole filter, that is Swizzy Gole filter, to smooth out the raw signal. Like if there are any noisy signals, the this filter will remove that signal. Then we fit the consecutive subject of neighboring signals point to smooth noisy signals. Here you can see we have a first raw signal, then we convert that into the smooth filter. We will apply then the time DWT formula on this filter. Then we extract the feature. Here is the DWT formula. Like as the feature are the most important part of classification process, we use discrete wavelet transformation based features. It uses multi-state decomposition to transform an input signal into a series of wave. Analyze on signal can be performed at different frequency bands. Like here you can see we have an input WG signal. It will convert it into higher and lower frequencies. The higher frequency will call the gamma frequencies and the lower frequency will call into A1. Then A1 converted into beta frequencies and the A2, then A2 in converted into D3 and A3. Like here we will only use the gamma bands because we use the higher frequency bands. In the higher frequency we will see there will be some spikes that will cause a person to detect he is addicted or non-addicted. Here are the results of feature extraction. Like first we apply the bands, like in the previous we applied the Asgole filter and get the data. Then we apply the DWT formation. Here you can see we have the gamma band, the alpha band, theta band, the delta band and the beta band. We use the gamma band because here you can see we have the higher frequencies. So in the higher frequencies we get the data of spikes. So using that spikes we will get the addiction and non-addiction of the person. Coming toward the result and discussions, in the result and discussion, we use the artificial neural network, that is ANN, and we use the subject-wise classification. Like we use the 23 people for one video game. Here you can see we have number of neurons, number of hidden layers, and the activation functional layer, input, hidden and output, optimizer, accuracies. Here you can see the number of hidden layers. We first apply the number of hidden layers, that is 1, then we apply the different number of neurons, that is 2. In the first you can see we applied 2 neurons. Like in the first hidden layer we have applied 2 neurons. The input layer is ReLU, the output layer is sigmoid, and the hidden layer is ReLU. Like we know that the ReLU is the only layer that convert a linear function into non-linear function. Like we get the non-linear at the output. So this will optimize using 0.0001 accuracies, and the accuracy that we get in the ANN, that the highest frequency is 60.06. Now here coming toward the gamma band accuracies, like I already described, as we have got the higher frequency that is 60.06 on the ANN using number of hidden layers that is 2. The number of neurons were 14 and 16 in the hidden layers too. So we applied this number of neurons and this number of hidden layers, like number of hidden layers were 2. We trained the model using ANN of 20 subjects on the gamma band. Then we applied the k-fold and get the average accuracy. Then the number of epochs that were used was 10. This was the training data. Like classifiers, we have used the random forest decision tree, KNN and ANN. You can see we have got the maximum frequency on the maximum accuracy on the KNNs. Like how we get the maximum accuracy on the KNN? On the KNN, we got the maximum accuracy because in KNN we have the neighbors element. Like in the neighbors element, we have a cluster of addiction and non-addiction. So in the addiction cluster, if we apply a external input of double digit signals, then we get the maximum data. Coming toward the WG lab part, we have analyzed data on WG lab. For analyzing, we have generated heat maps in WG lab and plotted the addicted and non-addicted power spectrum density graph. The process was following, like we first import the data in the WG lab. The noises are removed using the baseline tools. In the baseline tool, we will remove the data from the first part and the second part. Like we have to remove the first 10-second part. So we will apply the baseline tool. It will also remove the base signals. Then we applied the FIA filter on the data to smooth it down. Here you can see we have a graph of power spectrum density of O1, O2. Here you can see we got the maximum frequencies on the spectrum data. Coming toward the conclusion part, first we will apply the ANN model, then we applied different classifiers using artificial intelligence, and we get the different data on different accuracies of different classifiers. Then we apply the EEG lab data, then research and prediction. Like after applying the data, we get the accuracies on different bands. Like in the KNN, we get the higher frequencies. So in the prediction for the future recommendation, in the future recommendation, we get the fake responses. The current study will explain more than the EEG lab and then the prediction results. Like if we get the data of 23 participants, in future we will get the data more than 100 participants to get the fake responses excluded. Here are some references that we used in our slides. Here are some references, like the references of news are also given. Here are some references of papers. If you have any query regarding this, email us on given email address. Thank you.